Alright, so what I'm talking about tonight is the non-commutative approximation of a fractal. And what one of the significant clues in my research was when a publisher contacted me to publish my master's thesis on music theory and what I called sound current non-dualism. And he was a physics major, and he wrote books on math and music and physics, and he said he was going to promote my book at the publisher book fairs like in Germany. But then he kept asking me questions about my master's thesis, and he said he didn't understand what I was trying to communicate. And then his name was Charles Madden. And he finally said, actually it was my wife who wanted it published. And so then I read his book on fractals and music. And in that book he says the Taiji symbol, the yin-yang symbol, is not a fractal because it's not self-similar. So why isn't it self-similar? Because the black and white changes based on the scale, and that makes it self-affine or affine. The scaling is different in each axis, and so now basically this math is that I'm going to go into the math again later, but they're essentially saying that when you convert the exponential into the logarithmic form, then you're able to realize that it's actually non-commutative and self-affine, and therefore not a fractal. And so people, they learn about fractals, but so this is what it looks like. And so you can see as the scaling is different in each of the axes. So when you magnify the when you zoom in, the object changes. Okay, so so now they're talking about, this is the Sierpinski gasket, or the Sierpinski triangle. It's one of the more famous fractals. But they're saying that if you really want to understand it, you need to realize that it's actually this non-commutative version of the Sierpinski triangle, and that it's also called, this non-commutative version is also called the harmonic gasket or harmonic triangle. And so when we go back to music theory, we see that the log 3 divided by log 2 is the approximation from the non-commutative perfect fifth that does not ever go into the octave. So in the mathematics of the Riemannian, the Riemannian sphere, they use this they actually use music theory. So here you have the F sharp and the F, and as with the wavelength, and so you have the octave, and the reason why it's a negative exponential is because then it's non-commutative, and so you're dividing the rational fraction is what here is the logarithm. When you divide it, then you subtract the logarithms. And of course my background is the actual music theory part of this. So I don't do the actual calculations. I just study the mathematical concepts because, computers do calculations, but as Roger Penrose emphasizes, due to the Gödel incompleteness theorem, the consciousness is not a calculation. And so this is about what I called in my master's thesis, sound current non-dualism, which is the consciousness, proto-consciousness of the universe. So here again we have this log 3 over log 2 as the spectral triple from Alain Kahn. And of course he explains how that is from music theory, that music theory is actually non-commutative. So they're using this again as the approximation, as the harmonic non-commutative Sierpinski triangle or gasket. So here they're going into the math, but essentially they're saying that you can convert it back into the logarithmic equation that's then self-similar again as a fractal, but it originates in the non-commutative form. And so the idea is here that the truth of reality is not a fractal, but it's actually the non-commutative quantum that's also non-local. And so you have to use the Dirac operators, and the non-commutative time frequency is the inverse frequency. That's why you have that negative exponential. So it's the inverse of the Dirac operator. So it's not just the inverse of the wavelength. It's the inverse of the frequency. So so that makes it like a reverse time. It's non-local because it's not a wavelength yet. It's not converted to a geometric wavelength. It's just a pure time frequency energy. So here we have the fractal analog of Kahn's theorem. Again, that's the Riemannian manifold, which is that music theory part I was talking about, that they use that, the equivalent of the equal-tempered music scale. So here you have the fractal on the left side, but they're saying that it actually originates from this harmonic non-commutative form. And so this non-commutative form then can be turned into an antenna as technology. That's a metamaterial. And right now the fractal antennas are all the rage. But in fact, as they point out, because the fractal is self-similar, you can't maintain an independent frequency. and so they're not as efficient as a non-fractal antenna. So if you use the truth of reality as the harmonic, non-commutative Sierpinski gasket, then you can have the advantage of a fractal antenna that people are all interested in, but it's not actually fractal. It's better and maintains the non-fractal independent frequency for each scale. So you have the frequency invariant. You need to have the frequency invariant is what I'm talking about. So then when it's self-affine, you have the further flexibility. So this goes back to the one blue, one brown mathematician, or one brown, one blue. Sanderson is his last name. He makes really great videos. So here he has the Sierpinski triangle, and he's explaining again. You have triangles that are 1/3 of each, and then if you drop the dimension by 1/2, then you get this exponential, which is converted to a logarithm, and then you get the dimension of 1.58. So you can see this is the same as the music, but Grant Sanderson, he loses the non-commutative truth of this from the music theory. So he's pointing out, as a fractal, it has a length of infinity, it's an area of 0. So you have to somehow figure out, well, what's the dimension? And so you can use a approximation spatially to get a limit that converges to the dimension. But he says to really figure out the dimension, you have to convert that exponential approximation to a logarithmic equation, and then you can turn it into a linear equation. But again, when it's non-commutative, this is a subtraction, and it's a negative exponential. So again, he's not realizing that the foundation of that's non-local is actually a non-commutative rational fraction that is explained in music theory from the basic truth that the undertone of 2/3 is C to F as the perfect fifth. So here you have the music theory, and then the overtone is C to G as also the perfect fifth, which is 3/2. So here they include 3/2 for the music theory, but they don't mention 2/3. And that's something I noticed when I was in high school. I just wondered, well, why can't 2/3 be it is a perfect fifth, so why it can't exist in the scale? Because if you include it, then you lose the commutative conversion to make it a logarithmic equation, and the music theory was the original logarithmic equation. So it's the original cover-up of that non-commutative truth, and that's what Fields Medal math professor Alon Kahns is pointing out. So ultimately, you can't see this gasket, this non-commutative gasket, as an antenna. It's still an approximation, but it's better than just this self-similar gasket. The harmonic gasket is better. And so they're going to make it into actual antenna technology. And I don't know if that's going to be top secret or if it's already being used, or but I would argue that that is the truth of like yoga, alchemy, meditation, is you have this noncommutative, harmonic gasket. And I'm going to leave it at that. And thanks for listening.